Hello Year 4, it's Mrs Lancaster here. Welcome to your maths for this week. We're going to be thinking about equivalent fractions all week this week. Remember, you've only got 4 days this week because Friday's an inset day. Okay, so you haven't got any maths or any learning to do on Friday. So we're going to get started just to have a quick brain warm up. Have a look at these 3 questions here and can you answer them, and come back to me in about a minute when you've done them all, and we'll have a look at the answers together. Right, how did you get on then? So what fraction of each of the shapes is shaded? Well, I can see in this shape here that I have got 9 parts of my whole, 9 is the denominator, and I can see that there are 5 of them shaded, so 5/9 is the fraction that's shaded here. In my triangle, I can see that there are 4 smaller parts, each of equal size, and I can see 1 of them is shaded, so here I've got 1/4 of the shape shaded. In the circle, I can see that I've got 1 part and 1 of them is shaded. So I've got 1 part out of 1 shaded, or 1 whole one. There are 7/7 in 1 whole one, so 7 would be your answer here. And if you have got 1/10, then you would have 10 equal parts. But because we've got 2 whole ones, we've got 2 lots of 10, which is 20. So hopefully you managed to do a good job on those. So we are going to talk about equivalent this week, like I said, and it's really important to understand what that means to help us with our fractions. And I've got some examples of equivalent everyday items or objects or things that we would come across that aren't fractions. And equivalent just means that it's equal in value, equal in amount, or equal in meaning. And I can see here in this first example that I've got 5 £1 coins, and they are equivalent to 1 £5 note. I can see that I've got a number sentence here, which is an addition one, which is 3 plus 3, and I know that's 6. And I know that that's equivalent to 5 plus 1, which is also 6. Equivalent means the same as. And if we think back to when we did our measures, when we did our length work, we were looking at the equivalent measurements for metres and centimetres, and we know that 1 centimetre is equivalent to 10 millimetres. So equivalent isn't a word that we haven't heard before in maths, but it's also good to just refresh our memories about what it means, because today we're going to be using it to think about fractions. Now I've got a representation here. I've got quite a colourful image for you to have a look at. What does it look like? Have a little pause, have a little think, and have a little chat with someone at home if you've got someone there. Tell them if you've seen this before, do you know what it's for, when have you used it in maths before, those sorts of things. So pause the video now and have a little chat. Hopefully you have recognised that this is an image of a fraction wall, and you would have seen these images back in year 2 and most likely in year 3 as well. This one might look different to ones you've seen before, but with a fraction wall that we can see that all the parts are the same size. So this would be 1 whole one here at the top. I'll just kind of put a little bit of annotation in it. So the blue would be 1 whole one, and then I can see that the next whole one is divided or split into 2 equal parts. So this is 1 part out of 2, so I've got a half, and obviously this is another half over here. And you continue down the fraction wall, writing in your fraction. So when I get to this green section down here, I can still see that I've got the same whole, but it's divided into different number of parts here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts. So I know that one of these smaller sections is 1/10. And then I go further down and I can see I've got here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equal parts to this 1 whole. So down here we're working in 12ths. Now notice, as our denominator gets larger, our part of the whole gets smaller. So that's something really important to remember as well. So if I was looking for equivalent fractions, I could use a ruler or something that's got a straight edge, and I could see that I could put the red line here onto this black line in the half. I'm just going to move it to one side slightly because I could see then that this was an equivalent fraction. This is the same point along the fraction wall. This would also be an equivalent fraction. This here would also be an equivalent fraction. I can see we've got some tenths that are equivalent, and it would be 1, 2, 3, 4, 5 tenths is equivalent to a half. And I can also see some twelfths down here, which would be 1, 2, 3, 4, 5, 6 twelfths is also equivalent to a half. So what you're going to do, your very first activity, is you are going to either, in the Google Drive, print out your own fraction strip, and this one goes all the way up to twelfths, and then with your coloured pencils, be a bit creative, a bit artistic, and give it some colours like this fraction wall here has got. It doesn't have to be the same colours, you can use whatever colours you want to, and then you're going to annotate it with the fraction. So just like I started doing here, you're going to think about how many parts are in the whole, and you're going to sort of annotate everything in. And we're going to be using that this week to help us with our equivalent fractions. Don't worry if you can't print it off the Google Drive. It is quite important that you do print this today, if you can, because we need to make sure that everything's equal and everything's the right size. So it is quite difficult for you to construct your own fraction wall. So if you can't print that off, then there is another option. There is this fraction line here, which is on Maths is Fun website. There is a link in the Google Drive that will bring you to here if you need to. And this is essentially the same kind of thing. This is a fraction wall. This one goes up to 16ths though, so it's a little bit bigger than the one you're going to make. But you can move the line along, and we can pop it on the half there, and it will show us all the equivalent fractions. We can see 2 quarters, 3 sixths, 4 eighths, 5 tenths, 6 twelfths, 7 14ths and 8 16ths are all equivalent fractions to 1 quarter. So that's another resource that you can use if you can't print it off today. But have a go at making your own if you can. So we're going to be using this then today, and we're going to just start off by having a little go together, and then I'm going to give you a little bit of tinker time to have a play to see if you can find out lots of different equivalent fractions. But I can use my fraction wall that I've created now, and I can drag along my little ruler here, and I can put it on 2/5. Now I can see that this is 1/5. So this must be 2/5 here. So I'm going to place my ruler, I'm going to place my red line on my 2/5, and I can see that it is equivalent to another fraction down here. And I can see that 2/5 is equivalent to 1, 2, 3, 4 tenths. Okay, so I'm going to write 4 tenths in there. So there are a couple of others for you to have a go at, just to get yourself used to using your fraction wall, either with your ruler or your straight edge, or the interactive one. So I want you to find equivalent fractions for 2/3. I said fractions, that should have given you a clue. And are there any equivalent fractions for 6/8? So pause now, have a little go, jot them down, and then come back and we'll see how you got on, see if you got them all right. Okay, wow, let's have a look. So 2/3 then. Well, I can see this part of my fraction wall here is the thirds part. And if this is 1/3 here, I'm going to annotate these in. So this next part along must be 2/3. And this final part here is 3/3, because I can see that makes up the whole. So if I move my little ruler, my little red ruler along to the 2/3 mark, so it's not going there, that's 1/3. 2/3 would be on this line here, 3/3 would be here, because we know 3/3 is equivalent to 1/1. So this is 2/3. Ooh, and I can see there are quite a few fractions that are equivalent to 2/3. I can see that I've got some sixths that are equivalent, so that would be 1, 2, 3, 4 sixths are equivalent. I can see there are some ninths. I've got 1, 2, 3, 4, 5, 6 ninths that are equivalent. I can see that there are some twelfths, so that would be 1, 2, 3, 4, 5, 6, 7, 8 twelfths are equivalent to 2/3. Okay, and then the final one to look at was 6/8. So I can see that my 8ths row is this nice purple coloured one here, and I want 6/8, so that's 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. Oh, and I can see that I've got some twelfths that are equivalent. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 twelfths. But also, if I go this way, I can also see that 1, 2, 3 quarters is equivalent to 6/8 as well. So make sure you're looking up and down the whole of your fraction line to make sure you've got all the equivalent fractions. So now it's time for you to have a little bit of tinker time. So 5 minutes, that's all, just 5 minutes to have a little play with either your ruler and your fraction wall, fraction strips that you've coloured in yourself. And you can go and check then on the interactive version that you've got them all right, or you can just use the interactive version to have a go and see what equivalent fractions you can find for, say, I don't know, 7/9, 4/10. Just do a mixture, a range, and see what you come back with. We're not going to talk about them. I just want you to have a little go at being confident with using both your fraction strips, your fraction wall, and the interactive one. So in 5 minutes, come back and we'll move on to the a couple of questions that we're going to get you to do today. Right, well, hopefully you had fun. So there are a couple of questions for you today, and you will find them in the Google Drive. Okay, so you have got 2 problems to answer today, and here they are. You've got an odd one out problem. So one of these images is the odd one out, and you need to tell me why. So you've got some lines here to explain that. Thinking about using your fraction language, so you might want to use the word part, you might want to use the word whole, you might want to use the word shaded, equal. So your explanation needs to have some of that fraction terminology, that fraction language in. And then we've got to sort the fraction activity. And we're going to have a little bit of a talk about that one. Now we're going to go pop back over to the slides and we'll have a little chat. I think you're going to find this one not too difficult. You're really good at odd ones out, but this one needs a little bit more explaining for you. So you have got to sort the fractions into the table. So you're looking for equivalent fractions to 1/4. Maybe you've already found some in your tinker time, and equivalent fractions to 1/3. And then there will be some left, and it says here, if it's not an equivalent fraction to 1/4 or 1/3, then you need to write an example of a fraction it is equivalent to. So for example, if 3/7 isn't an equivalent fraction to 1/4 and 1/3, and I don't know if it is or not, I haven't tested it out yet, I haven't used my fraction wall to help me. You've got to find one that is equivalent, so let's just have a go. So here is my, have I got sevenths on there? I haven't got sevenths on there. I wonder if I've got sevenths over on my fraction number line. I have, and it was 3/7, wasn't it? So 1, 2, 3. So I can see I've got 3/7 there, and actually if I look down I can see that there's only one other equivalent fraction for 3/7. Oh, it's disappeared. And it is there. It's 6/14. Look, can you see it right down the bottom there? So I am going to go back and I am going to jot in that 3/7 is equal to 6/14. That's odd, isn't it? I've spotted something. I can see that 3, if I multiplied 3 by 2, that would make 6. And if I multiplied 7 by 2, that would make 14. I wonder if that's another way to find out equivalent fractions. Maybe we'll have a little investigate of that in a second. So find something that's equivalent to 1/4. I would say that once you've found them, it's a really good idea to either put a cross through it or tick it off so you don't use it again. I wonder though, because I can see that this fraction wall here only goes up to 12ths, and I noticed that my interactive one only went up to 16ths. But I've got some fractions here with some very large denominators. How am I going to be able to find out if they're equivalent to quarters or thirds, I wonder? I wonder if I think about using my multiplication facts. That might help me to find some larger fractions. I can have a go on a little whiteboard and have a little look and see what I come up with, and maybe that's going to help you as well this week to find out about your equivalent fractions. So we've looked at using our fraction strips or our fraction wall for finding equivalent fractions, which is really quite helpful. The problem is that the ones that we have got access to use they only go up to 12ths or 16ths. Now, what happens if our equivalent fraction has 32 parts in its whole or 24 parts in its whole? We are going to need to find another way to find out those equivalent fractions. So if we think about the fraction 1/4, 1 part out of 4, we can do some multiplication and some division to find out equivalent fractions. So I know that if I multiply the 1 here by a 2, I get 2. And I know if I multiply the 4 by a 2, I get 8. So you can see that by multiplying the numerator and the denominator by the same number, we get an equivalent fraction. Well, that's great. We could multiply it by 3. And we can do 1 lot of 3 is 3, and we could do 4 lots of 3 are 12. So that's if we multiply by 3. We could multiply each by 4. So the numerator would be 4 1s are 4, and the denominator would be 4 4s are 16. Well, that's okay because we can find all those fractions on our number line, can't we? It's when we get to multiplying by 5 where things start to get a little bit more interesting. So I can multiply my numerator by 5 to get 5. I can multiply my denominator by 5 to get 5/20. And all these are equivalent fractions to 1/4. I can multiply my numerator by 6. I can multiply my denominator by 6. 6 lots of 4. Well, if I know 6 2s are 12, I know that's double, so that's 24. So it's really important to know those times tables fluently. I'll just end up with, I'll do multiplied by 7. 1 lot of 7 is 7, so your numerator is 7. 4 7s are 28. So this is another way for you to be able to identify equivalent fractions by multiplying the numerator and the denominator by the same amount. So the very last thing today for you to do is we've got a little game and it's called Sit Down, Stand Up. So I'm going to show you some slides in a second, and if the fraction is equivalent, let's pop over there now so we've got it. Is it going to work? Here we go. It's just taking a little bit of time. So it's called Sit Up, Stand Down. It's not called Sit Up, Stand Down at all. You can't do that. It's called Sit Down, Stand Up. And hopefully we'll go to the next slide in a minute. Right, so you're going to see two different fractions. You'll see the fraction and the picture. And you've got to stand up if the fractions are equivalent, and you've got to sit down if they are not equivalent. Okay, are you ready? Here we go. Hopefully it'll work. Fingers crossed. Just thinking about it. Number 1, here it is. 3/4, 6/8. Stand up if it's equivalent, sit down if it's not. I'm hoping you're all stood up. Good. Next one. 2/4 and 1/4. Is it equivalent? Yes or no? I'm hoping you're all sat down. Not equivalent. Number 3. Oh, where's number 3? There it is. 5, 6 and 2/3. Is it equivalent? Stand up if you think it is. Sit down if you think it isn't. You should be sat down. Those are not equivalent fractions. Number 4. Ooh, a number line. Stand up if you think 4/8 is equivalent to 2/4. Sit down if you don't think they are. You should be stood up. They are equivalent fractions. 1/3 and 4/8. You should be sat down. Those are not equivalent fractions. 1/3 and 3/6. I think you can see very clearly from those number lines that those fractions are not equivalent. We know 3/6 is equivalent to a half. Number 7. 10/12 and 5/6. Equivalent or not? You should be stood up. They are equivalent fractions. Number 8. 4/8 and 2/4. Are they equivalent? Yes or no? Stand up if you think they are. Sit down if you think they're not. You should be stood up. They are equivalent fractions. Number 9. 3/5 and 9/15. Yes or no? They are equivalent fractions. You should be stood up. They are equivalent fractions. Oh, gone backwards. And number 10, you can see quite clearly from that picture, that representation there, that these are not equivalent fractions. You should be sat down. Number 11. Yes, stand up. Number 12. You should be stood up. 2/6 is equivalent to 1/3. Number 13. Definitely should be sitting down for this one. 2/5 is not equivalent to 4/8. 2/5 is not equivalent to 4/8. Number 14, hopefully you can see that that is equivalent. You should be stood up. And number 15, 3/8 equivalent to 3/4. I think you can see from that picture they're not equivalent. You should be sat down. And number 16, 5/8 and 2/3. Are they equivalent? No, they're not. You should be sat down, and that is it. So we should have ended on a sit. Oh, gone back. Should have ended on a sit down. Oh, it keeps popping up now. I don't want it to. Right, okay. So your challenge. That was quite a nice activity, got you moving up and down, up and down. Can you create your own equivalent fraction activity, I wonder? Maybe get a bit of action in it. Maybe you could do stand on one foot if they're equivalent, jump in the air if they're not. I don't know. I'm going to leave it up to you, but it'd be really nice to see some of your activities that you come up with today. Everything you need is on the Google Drive, including all your links. So I will see you for maths again tomorrow. Have fun and make sure you come up with some really fun activities, and maybe we could try them this week in school and in our Zoom calls.